Hello everyone, so welcome to our video on one of the most important topics in calculus, which is technique of differentiation. So, differentiation is the process of finding the rate at which a function changes. It's fundamental concept used to understand slope, motion, growth, and many real-world applications. So, in this video, we will explain and demonstrate several key techniques including the power rule, product rule, quotient rule, chain rule, some different rule, implicit differentiation, also algorithmic differentiation. So we go for the introduction differentiation, a fundamental concept in calculus that deals with finding the rate of change of a function. The technique of differentiation provides method for calculating the derivative of a function which represent this rate of change. The process of finding the derivative of function, the function at a particular point represent the rate of change of the function at that point. It represents the slope of the tangent line to the graph of the function at that point. So let's begin our journey to better understand how differentiation works and why it's such a powerful tool in calculus. So first, technique of differentiation in calculus. First, power rule used for differentiating power function. Second is product rule used for differentiating the product of two functions. Third is quotient rule used for differentiating the quotient of two functions. Fourth, chain rule used for differentiating composite function. 5. Sum or difference rule. The derivative of a sum, like or difference, of function is the sum of their derivative. Second last is implicit differentiation. It used for differentiating implicitly defined function. And the lastly is logarithmic differentiation, useful for simplify the differentiation of complex functions involving products, quotient, and powers. Okay, so we go for the problem statement. For the question 1, explain the meaning of differentiation and what are the techniques of differentiation. 2 is find dy per dx for the following function a and b. And the question 3 is given for finding dy per dx using implicit differentiation. And the last question is question 4. Use linear approximation to estimate the value of correct to three-dimensional places.
So for the next question, this is the answer to the question 1 to x minus 2x. Although we solve this question together. For this question, we have to use function by already solve this question with functions. The formula that we have to use for this question is dy by dx to 4x u prime square minus u prime over x plus square plus bracket. Then we have to label where is step u and v. We have to use which is z. Then we label question u for 1 to x minus 2x and we have to use for x plus y. So next v1 plus v u prime using the formula given. And then next, we first step u equals to 1 to x minus 2x. We get and then u prime equal to 2x u prime to x minus 2x. And then the next step is v to x equal to 4 square open bracket c and x plus 3 close bracket. We calculate the x, follow the formula, so we get the answer is which is 2 to x 2 minus 2 10. And then next, the square is we have to do 3x plus y. In front of our answer is we get 9. The equal to 3 is then 4 to v square x plus 3 close bracket multiply like it's 2 square sin and then plus 3 we have cos there we have 3 got the answer. And then the overall we get the we have to arrange them square bracket sin to make us easy close bracket C then multiply to 6 square. Bracket next in x plus 3 cos bracket we have write the cos x plus 3 bracket 3x plus 1. Cos by my name is Camila Fadalina. This is the answer for question number 2. Let's see how we solve this question together. We have so the question is find dy over dx minus functions. So for question A, ln 2x minus 2x, which is minus 3 equal to 4x over plus x 1 square open bracket c x plus then we have bracket to multiply it. Next step to get the another we have to use chain rule to copy. And next is equation. We multiply it. The formula that we have to use for this equation is x ln to u minus prime 6x plus 2 ln to x prime. And then next we can take 4x minus 2u minus 3 and then 2x plus 6 over 3x plus 4 square. So the final answer is 6x and then 2x. The next step is x minus 2. We take over 3x plus 1 square bracket c x. So for the next equation is and then y equal to the formula 2x minus 2x over the 3x plus 1 which is equal to this question. We have to use question rule to solve this question. Square, we have formula that we have to use for this question. 5 of 10 dy over the x equal to v u prime minus u prime over bracket v square x plus 3. Then we have to label bracket over x so add v sin x plus we can see bracket and then x plus 3. We label and then for follow we can do x minus 2x and plus 2 then 3x plus 1 square over so next see 1x plus 3 to solve bracket equation using the formula multiply to 6 squares u bracket to ln 2x plus 3 minus 2x multiply to cos and then u plus 3 equal to 2x ln 2x minus 2x. We have to this is the answer for equation number 2x. Let's see how we solve this question together. And then so the question is find dy by dx for the following question. So the question is 2 ln 2x which is y equal to 4x plus 10 square. The v is equal to 3x plus y bracket. And the final answer is v prime. The next step equal to 3. Therefore, use chain rule v square to have this equation multiply it by 2. The formula that we have in the next equation is after we use v prime got the answer is v u prime. We have to next step we can take 4x to put at u to make us easy to get c and multiply and cut to u prime. The next and then the next we have is v. We take the open bracket square x plus 1 bracket c x plus 3 open bracket. And then to follow the formula to learn to x prime minus 2 is we have to 2 10 minus square we have to bring at ln 2x in front of x times 3 and then the over answer is 1 square to 10 open bracket and then we have plus 3 to multiply cos bracket open bracket to get the another x plus 3 cos bracket and cos x plus 3 next after and then multiply it we get the 4 plus 2 10 6 square open bracket 6 x plus 3 cos bracket to x multiply to 6 square open bracket minus x.
So for the next question is given 2y over x plus 5 ln 5x ln cos y equal to 5x 3 plus 2. So we have to find dy over dx using implicit differentiation. So we have to find dy over dx. So we have to write back the question, which is 2y over x plus 5 ln 5x ln cos y equal to 5x 3 plus 2. Then we make it 4 part, which is a, b, c, and d. For part a, we have 2y over x. For part b, 5 ln 5x ln cos y. For part c, 5x 3, and part d is 2. For part a, we have d open bracket 2y over x close bracket over dx equal to 2 times y over x. Then the next step, we write d over dx times y over x equal to x dy over dx minus y times 1 over x square. Then we get the answer is d over dx times 2y over x equal to 2 times x dy over dx minus y over x square. For part b, we have d open bracket 5 ln 5x ln cos y over dx. For this part, we have to use chain rule, which is the formula is v u prime plus u v prime. We can take the 5x for u and ln cos y for v. Then we solve the question. We take u equal to 5 ln 5x, so we get the
answer for u prime is 25 ln 5x. Before that, we have to bring the 5 to the back to get the answer u prime equal to 25 ln 5x. Next, for v, which is ln cos y, then we write d over dx, over bracket ln cos y close bracket. Then we have to bring the cos y to the front and d over dx to the back. So we get the answer y over cos y, negative sin y, y dy over dx. So the answer for v prime is equal to negative 10 y dy over dx. So the overall answer for part B is d over dx over bracket ln cos y cos bracket equal to 25 ln 5x ln cos y plus 5 ln 5x negative 10y dy over dx. So part C, we take d open bracket 5x 3 close bracket over dx equal to 50x square times 2 dy over dx. So the last part is d, which is d in bracket 2 over dx equal to 0. For this part, we have long solution. So next, we take 2 to the front, so we get 2x minus dy over dx minus y over x squared plus 25 ln 5x ln cos y minus 5 ln 5x then y in bracket dy over dx equal to 15 squared dy over dx. Then next, we solve the solution. So we get the 2x minus dy over dx over x squared minus 2y over x squared minus 5 ln 5x then y minus dy over dx plus 25 ln 5x ln cos y equal to 15x squared. Then we remove the dy over dx, so we get the 2x over x squared minus 5 ln 5x then y equal to 50x squared plus 2y over x squared minus 25 ln 5x ln cos y. Then we cut the x, we cut the same number, so we get 2 over x minus 5 ln 5x then y dy over dx equal to 50x squared plus 2y over x squared minus 25 ln 5x ln cos y. So the final answer for this part is dy over dx equal to 50x squared plus 2y over x squared ln cos y over 2 over x minus 5 ln 5x then y. That's all for me. So for the next question, it's given 2y over x plus 5 ln 5x ln cos y equal to 5x 3 plus 2. So we have to find dy over dx using implicit differentiation.
With using linear approximation to estimate the value of the expression square root of 80.99 minus 2 over the square root of 80.99, correct to 3 decimal places. First, define a function fx where fx equal square root 4x minus 2 per square root x. This can also be written as fx equal x power 1 per 4 minus 2x power 1 per 2, which will make it easy for us to differentiate. Next, we choose a value of x0 that is close to 80.99 and it's easy to work it. In this case, we select x0 equal 81 since the square root of 81 is a whole number. We want to estimate f 80.99, so we set x1 equal 80.99. The change in x or dx is given by dx equal x1 minus x0, which is 80.99 minus 81, and that's equal negative 0.01. Then calculate the derivative of fx. The derivative of fx equal x power 1 per 4 minus 2x power negative 1 per 2 is f prime x equal 1 per 4x power 1 per 4 minus 1 minus 2 multiply negative 1 per 2 x power negative 1 per 2 minus 1. This simplify to f prime x equal x power negative 3 per 4 minus x power negative 3 per 2. Then f prime at 0 equal f81 equal 1 per 4 multiply 81 power negative 3 per 4 minus 81 power negative 3 per 2 equal negative 1 per 972. Now we substitute to the df equal f prime at 0 dx, where minus 1 per 972 multiply negative 0.01 equal 1 per 97200. For the new value, f at 1 equal f at 0 plus df. Substitute at 0 equal 81 into the derivative and find that 81 power 1 per 4 minus 2 multiply 81 power negative 1 per 2 equal 2.778. Finally, to estimate the value for f at 1, adding f at 0 and df will come 2.778, we correct to the 3 decimal places. In conclusion, the technique of differentiation are essential tools in calculus that help us analyze how functions change. Whether it's use the product rule, quotient rule, change rule, sum or difference rule, implicit differentiation, or logarithmic differentiation, each method allows us to handle different types of functions with accuracy and logic. Through the video, we'll explore how this technique applied in real problems. Help us understand the rates of change, slope of curves, and much more. Mastering these rules strengthens our problem-solving skill, not just in mathematics, but in science, engineering, economic, and everyday situations. Thanks for watching, and we hope this presentation help you grasp the importance and application of differentiation in calculus. Before we end, here are the references we used to prepare this video. Bye bye!